In this video, we're going to go over Juniper Networking Basics. vSRXs, we're going to set up basic routing and zone-based firewalling. This is Epic Home Tech. My name is Jeremy and my co-host Jared.
Hello.
And let's get started. So we got GNS3 started. We've got our vSRXs laid out and they're already running. We're going to go ahead and get our diagram put together. So let's go ahead and name our devices. This one is going to be called left. We're going to call this one right. And we're going to call this one the internet. All right. We're going to cable them up. 0 to 0, 1 to 0. I'm going to go ahead and number our segments just to get the whole process going nice and clean. We're going to go 1, 0, 24 here. We're going to go. Oh man, having a tough time typing. Almost. And 2, 0, 24 here. And then we're going to go ahead and the internet is going to be .1. I always recommend you get your drawing put together so you know what you got going on. Makes it much easier to keep all of your numbers organized. And we're going to do .10. Just because, why not? There we go. All right, so there's our basic layout. So we're going to get left set up. We're going to be traversing through the internet to right. So left and right are separated by at least one hop, which means we're going to have a static route going between or a default route if that's what you choose. Since this is the internet, a default route could work just as well. We'll probably do a mix of both. How about we do a default route on the left and we'll do a static route on the right. For the internet, we're going to have to create a left and right zones, and we'll have to create a policy allowing traffic between. We could put them both in the same zone and use a single policy, but I think we'll just do two separate zones. I think that'll be fun. So let's see where we're at with our booting. We're still going. That's not a problem. We'll get all of our consoles put together while we're doing this. So we'll tell that to localhost, and internet is 5002. And we'll tell that to localhost 5004. For anyone who watched our first video about Juniper Basics, just setting up the network interfaces and connectivity, a lot of this will be a good refresher for you. For anyone new, go ahead and pause the video as you're progressing through if we're moving too quickly and you need to catch up. Right now we're just waiting for everything to boot.
Repetition is the key.
That is definitely true. Especially if you're coming from a Cisco platform, getting the muscle memory broken and into a new, better way of thinking and operating definitely takes time.
That's what I was used to. Cisco, yeah. And then just getting used to the different, I don't want to call them menus, but the syntax and what means one thing on one side, and it's hard to hop between the two. At least it was for me.
Absolutely. And I came from Cisco world as well, but you get used to it pretty quickly. A lot of information there. Creating initial configuration, so this is the first time these machines are being booted. Should all be booting at more or less the same rates.
Looks like it.
So again, for anybody who's just getting started, save yourself some memory and bring down the RAM usage for these machines down to 3072. And don't forget to change your network if you're on an Ubuntu machine running QEMU. And we're using the vSRX 3s. Strongly recommend it.
One question I have, Jeremy, is if you're counseled in directly into a Juniper, is there anything different than what we would see here in GNS3 versus actually being plugged directly into a Juniper router as far as setup or anything like that on a first startup? As far as getting into it or anything like that?
Not in my experience. The experience between the two should be more or less the same. I don't think there'll be any significant differences. Not with these vSRXs and not with a hardware appliance. The exception is with AWS vSRXs, since you don't actually have the console, so you can't actually access the serial interface. The experience will be different there. You're not going to be able to do any sort of password recoveries. That's not an option. So, as far as what you'll see booting up, it should be more or less the same. Minor discrepancies, things like DPDK.
Okay.
DPDK, I don't believe exists on the majority of the hardware platforms. Some may have DPDK if they're the x86 based platforms, but I think that all depends on what versions and what hardwares. The ASICs that they're using for the switching modules or the interface modules may not be DPDK compatible or use DPDK to access them. They might have other proprietary drivers or kernel interfaces. But otherwise, it should be more or less the same. Obviously, you'll have a USB interface that you can play with, and accessing the USB serial interface is a possibility with a hardware appliance, which
Perfect.
works very well on the SRX platforms. But for whatever reason, the USB interface does not work as well on the EX platforms. It was very odd. It's very hit or miss with the EX platform.
Okay.
So we'll go ahead and get left started up here. We'll go edit, load, override terminal, mash it a couple times, Control D, set system, root authentication, plain text password, enter a password, enter a password again, and we're going to set system host name, and we're going to call this left. We're going to go ahead and commit that just to clean out the config. And we're going to go through the others and quick get them taken care of so we don't get lost. So that was the internet. And that's right. Let's go back to the internet, wait for it to finish loading the CLI. Edit, load override, terminal, Control D, set system. We'll do host name, and we'll call out internet, root authentication, plain text password, type in a password, type in a password again, and we'll commit, and we'll do the same.
Now, when you're setting something up like this, do you like to hop between and get them all at the same point, or do you like to start one, finish it, and then move on to the next? Or do you find like the thought process moving from one to the next, if you're keeping them kind of in the same area, that you're less likely to forget things?
I will typically do them one at a time, at least to a point. Get them to a point where they can do, basic ping, verify connectivity. And then if I'm going to be adding additional, routing protocols, then I'll add routing protocols, verify routes are being exchanged. If, ping traffic is supposed to be passing, then I would test it again, make sure that I can reach, segments that are one hop away. I wouldn't typically, even in a production environment, be operating multiple devices if I can avoid it, simply because you start getting lost in which device you're working on. Unless you're troubleshooting multiple pieces, I try to keep it contained, keep it focused on a single system, and I maintain an understanding of my progress and where I'm at by leveraging a diagram. I might start scribbling on the diagram. I got, layer 1, layer 2 connectivity set up. I'm setting up the VPNs or something.
Okay.
Otherwise, it becomes so many numbers and it becomes so easy to mistype them, putting in the wrong IP addresses in the wrong places.
Sure.
It's very difficult to chase down when you start jamming IP addresses in the wrong places, or forgetting you're on the wrong device and applying the wrong configuration, especially if it's a production device. Never a good day. All right, so we got our host name. Let's go ahead and set our interface. So our interface is GE000 and dirt unit 0. Family INET for IPv4, and our address is 192.168.1.10, and our CIDR mask is /24. So we're going to create a security zone because these devices are security first. We're going to call this zone WAN, and we're going to allow ping traffic. We'll allow other things, but we'll just start with ping for now. 000.0. And we'll go commit check. So what I'm going to do is I'm going to get left set up with its interface and its address. Then I'm going to get internet set up for its interface and address. Probably do both interfaces, but I'm going to verify the left segment first. Then I'll work on right, verify the right segment. Then I'll go back and create the routing policies on the internet and create whatever routes I need between left and right, and then verify they can ping.
That's like a plan.
All right, so left is configured. So let's go run show. Interface is terse. And we see GE00 is not working.
Hmm.
Zero, zero. It does show up. Oh, why don't I see my unit? Oh. Helps when you actually commit the config. Set interfaces.
Was it just
0.
a commit check?
Yeah, yeah. Family INET 192.168.1.1. Oops. Address. And boom. All right, so show interfaces. There we go. Let's go ahead and set some descriptions just because we can. And description to the left. To the right. All right, set security zone left, host inbound traffic, system services ping. Need to put the interface in there. Security zone right, host inbound traffic, system services ping. G0010. I'm going to use show compare, see where I'm at, what I got going on. So there's my security zone left, host inbound traffic, system services ping. Interfaces GE000.0, security zone right, host inbound traffic, system services ping. Interfaces GE001.0. We got our interface configuration 000. Description to the left, unit 0. Family INET address 192.168.11/24. And 001 to the right, and 192.168.21/24. I think we're good. Let's commit that. Good. And we're going to go run ping 192.168.1.1. Still committing. Look at my CPU. It's up over 80%. All right. So there we go. We got some pings. Why is my CPU so high? All right. So left to internet is good. Now let's set up right. So what do we have going on in here? Just the password and the host name. So set interfaces 000, family INET 192.168.2.10. Family INET address 210/24. Set security zone WAN, host inbound, system services ping, and interfaces GE000.0. Right. And I think we're good.
Yep.
Let's commit that. And then we're going to verify that right can ping internet. So when we look at the internet device, for 2 segments and for the traffic that's going to be traversing it, we won't need any routes because they're all local. They're all direct attached segments. So we can see that for our protocol direct, which is direct attached segments, we see the subnet that we're looking for, and we see the interface that's associated. We see the same for the 2.0 network and its interface. So for the traffic that's going to be coming from left to internet, it will stay on this segment, so it'll be local. From right to internet, it will be local. When we try to get traffic from left to right, however, if we look at the route table, we see that there's nothing in the route table for 192.168.2.0. We also do not see any sort of default route options in here. So that would be a 0.0.0.0/0 route, and there's nothing there. So trying to reach this will black hole. It will not route since there is no active route. We will have to create one. So let's go ahead and verify from right to internet. Making sure we're good to go there. All right. So let's go to left and let's create a default route. So we'll go set protocols static, isn't it? No, wrong device. Routing options, static route. So I was thinking of BIOS, and I think Edge router, you use protocols static. Set routing options, static route, and we're going to go 000/0. And next hop, 192.168.1.1. So show compare, and we see we've got a routing options, we've got a static route, and we're going to go ahead and commit that. However, on the right device, we're going to go set routing options, static route, and we will go 192.168.1.0/24 and next hop. So next hop is always going to be the interface that is next. So from right, it needs to reach an interface address or an IP address on the segment that is directly attached so that it knows how to resolve that to an interface so that it can send it. So right will need to have the .1 of the internet router for 2 networks since that's locally connected, direct attached. So it'll be 2.1.
And just for reference, Jeremy, when you're saying, static route 0.0.0.0, that is a catch-all, correct? Just for somebody who maybe starting out.
Absolutely. So in Cisco, they do, I believe, use the term default. However, in Juniper and other platforms, they will use a 0.0.0.0/0 route. That means any IP address matches this route. It will still follow all of the rules of route selection. So if we go run show route now, we will see 0.0.0. It is static. Static will be preferred less than a direct. So even though 0.0.0 matches 192.168.1.1, this route will be the preferred route since it has a lower metric because of its protocol direct. So 0.0.0. This can also be shortened to 0/0, and Juniper will accept that. You can type that in anywhere. All right, so we created our route, and we're going to go ahead and commit. All right, so now we've got routes going from left to right. So here is a route that gets from left toward internet for all IP addresses that don't match else. And for our right, we have a 192.168.1.0 route. You see it's static, and it has an address to send it to. So the important thing here is that while the two routes don't match, they will both work because they both match the traffic and send it to the right next hop. So that's where you got to apply a little bit more network understanding if you're going to have to start dealing with some of these other things, because while the routes may not match perfectly in all scenarios, it's important to remember what you're looking to match. So you can go run show route, and we can say we want to route to 192.168.1.23, and it will show you which routes match that address. So it will tell me that for this address that I'm trying to reach, this is the route that matches. This is the route that would be selected since it is active, and this would be how we would get there. The important thing to note when you begin trying to determine why something's not routing properly is using something like this. You have your address, you know the destination. So find the routes that it matches and then check what its next hop is. Also check its interface. Maybe for whatever reason you're working with a remote tech and they told you that they plugged it into port 3, but your route is configured and as well as your IP address on port 0. This makes it very difficult for traffic to arrive at its destination since it's not using the correct port. So you'll have to make sure that as you're working through these issues, you look at some of these basic things. Because while, it seems basic to you, there may be a miscommunication between you and the remote, technician or an office worker that's helping you troubleshoot this. Make sure that you challenge your assumptions. Be respectful, but make sure you ask questions. And if questions and answers aren't getting you where you need to go, everybody's got a phone with a camera. Have them take a picture and say, hey, why is that cable in port 4 or port 3? I wanted you to plug it in port 0.
Yeah. even better, right? A good diagram sent to the technician on site on how to cable this thing up would clear up, hopefully, any issues on which ports to use, but it still happens. I'm guilty of it myself.
And it's good practice. It's good practice, right? If you've got your documentation done ahead of time, you don't have to do it afterwards. And then everybody's looking at the same, sheet of music, following the same instructions. I do try to do that when I'm working with a remote tech, especially if I sent them instructions. I try to have those instructions available to me as well so that I can reference the exact same documents. I can reference the exact same words. I can reference the exact same pictures. So I can say, hey, Jared, all right, in the diagram, you see where I have the switch and there's, 3 cables, and make sure that the second from the right is plugged in properly. There we go. Now I see it. We're good to go. Might have had a bad cable or something.
Sure, and even just setting a standard in general, right? You're not going to switch ports up. I might send one site, a Juniper, and I'm going to have them plugging into 002, but this other site will be 000. It's consistency that is the recipe for success.
Yes,
if you're going
it
to
definitely
have the
makes it
same
easier.
setup in multiple locations, it should be the same exact way of plugging in. Even if you're not dealing with the same person, at least for your reference, you know that you didn't change the recipe.
Absolutely. All right, so let's go ahead and let's get a ping going from left to right. So we're going to run ping 192.168.2. We'll go 2.10. All right, so 2.10, the traffic's not going to pass. However, it's not telling us we don't have a route. So if you had no route, it would say no route to host. But we have a route, or there's a route in the table. And we're getting a ping. So the ping is moving. All right. What we have now is a situation where traffic is likely, we haven't proven it, and I don't know if we'll be able to. Let's see. Run show traffic. Sorry, interface. Show monitor traffic. Yeah, I didn't think so. All right, so in Juniper devices, ICMP is handled differently than a lot of other traffic. What I mean by that is ICMP is handled on the data plane, so you never actually see it in the control plane, which is where the routing engine and the management interfaces are. So in this one, that ICMP is being handled, received, and what have you by the DPDK data plane. So we won't see this. On your hardware platforms, it's a similar function where they have the ICMP traffic handled on the data plane of the device. So ICMP requests will come in and go out, be received, and traffic responded to at a level below the visibility of the routing engine. So we won't see this traffic. Otherwise, this command should have shown me all traffic available, not available, all traffic coming in and going out of the interface. All right, so 2.10. All right, so we have security zones We have security zones created, left and right, but we don't have a policy allowing traffic to go from left to right and right to left. So we're going to go ahead and we're going to start doing that. So we're going to use the edit command, security policies. And when we do a security policy, it's always directional. So you have to make sure you're referencing the from zone and the to zone. So we're going to go from zone left to zone right. All right. So now we have to create a policy. All of the policies are named. So we're going to call this allow ICMP. So we're going to set policy allow ICMP. And we see that we have plenty of options. With Juniper, there is always a match or a something and then an operation. So with these security policies, we will be matching traffic that we're interested in. So we are going to match where the source address is any, the destination address is any, and the protocol, application is Junos ICMP all. Junos ICMP all. Okay. So now we see our policy allows ICMP match source address any, destination address any, and application Junos ICMP all. We also receive a warning because we have not configured a then. So that's the action statement. So we're going to set policy, we're going to allow ICMP, and we're going to do then permit.
That would bite me every time.
Yeah. The policies by default are an implicit deny at the end of your list. So here we see allow ICMP. After this, there is an implicit deny. If you wanted to create an explicit deny, you can do that for a very specific reason. If you wanted to count or log all packets that were not being denied, keep in mind that in a production environment, this would be a bad idea and unnecessary in most cases. You're not terribly interested in the things that you successfully deny. You're more interested in the things that you successfully permit, or you log or count very specific protocols for very specific reasons. And the reason for that is, especially if this is an internet attached device, the internet is a filthy, filthy place, and lots of people are doing lots and lots of things to a lot of devices. You can have bad actors out there trying to scan your device for vulnerabilities. You can have, good actors out there just trying to collect statistics. But at the end of the day, your device is sitting there constantly receiving traffic, receiving requests for sessions and connections, and you don't need to log all of the world's garbage. So focus on what you want, what you're interested in, and don't log or count any of the garbage you're not interested in. If you do set it up to log, you can find that it will start consuming a lot of storage space. Or if this is a small device like an SRX 300 series, you can start burning the cells on the flash memory. I think it's got some solid state memory on the board, which you don't want to just start wasting pointlessly with a whole bunch of garbage log data for traffic that you didn't care about anyways.
Sure. That was the next question I was going to ask, is what it did to the device.
Yeah, it'll definitely burn out the storage eventually. Of course, this is one of those, your mileage may vary, right? If you've got a larger 300 series, it might have more storage and you won't burn out the solid state memory as quickly. And it might be one of those where the solid state memory won't burn out for 5, 6, 7, 8 years. But damaging the solid state memory will happen. It always happens. It's part of what the kind of fundamental flaw of solid state storage, right? It's only got so many writes that you can do to the memory. So this is just an unnecessary thrashing of that storage. If you are logging to syslog, however, or something like that, you can have the logging data shipped that way rather than being committed to disk, and you can filter out some of that stuff. So that would be a viable option if you wanted to collect that information. Do keep in mind that, of course, if you're going to be logging all of your packets, especially the ones that you discard, the garbage ones, it will be generating traffic on the inside of your network. So keep that in mind. All right, so we've created our left to right zone. So we've got our allow, our permit, ICMP, and our implicit deny. What we need to do is create an equal policy and an identical policy going from right to left. So we can do that with a copy statement. So we're going to use our up command, and we're going to copy from zone left to zone right to from zone right to zone left. The command is strange, especially when you're using it this way. You're doing a copy, and this is the name of the policy. From zone left to zone right. You're copying this to this.
Sure.
When you get into a device where you've got long zone names because you've got a large piece of equipment, I strongly recommend using copy and paste or working in your configs in a text editor like Atom or Visual Studio Code or something like that, even Vim, where you can manipulate things a little bit more effectively, and then loading the config into the device. And we'll get to that in later videos where we start talking about bigger configs and copying the configs out, manipulating them out off the device, and then loading them back into the device.
No, so I do have a quick question. If you were to start a ping from left to right, if we were to go onto the right device and monitor traffic there, we should see kind of what you were trying to do earlier, right? We should see that interface receiving, correct? The 192.168.2.10.
I don't think we will, but let's give it a shot.
Or no?
Let's deactivate. One of the nice things about Juniper, if you're coming from Cisco, is you can deactivate sections of code, which means it's still there, but it's not actually active. It's not doing anything. It's not in play, but it's still there. So I can disable a security policy. So we're going to deactivate from zone right to zone left. And we're going to commit this. So Jared's question is, with our ping going from left to right, with only a policy of left to right, will we see the traffic on right? So let's see. We're going to go run monitor traffic interface 00. So this again is where that ICMP is handled differently.
Okay, same thing then. Yep.
Yeah. What we could do is we can go show. We can set, no, I don't want to save the file then. Set from zone left to zone right. Policy allow allow ICMP. Then count, and we'll commit that. So the count command will activate a counting function. So it will begin incrementing a number, counting all of the packets that match the policy. So run, I got to remember the command, run show policy. Woo. It's thinking.
There we go.
Man, it does not like that. Ooh, tab complete is slow.
CPU's was up to 80% there.
Man. That is wild. That is wild. Those VMs are soaking up a lot of CPU. I'm going to have to remember that for future videos. All right. So show policy statistics. It told me invalid policy. But I don't think this is the right command anyways. Show security. What's the command for counters? I didn't want policy, I want security policy. That's not it either. Policies count. A number of policies to show. That's not it. Hit count. There we go.
There we
All
go.
right. So after we went through that long process, we found show security policies hit count. So a logical system. So this is something that you will see when you start getting into bigger networks. Logical systems allow you to create a logical partition within the routing and data planes. So the routing engine, so the data and control planes. Then you can ultimately have two separate devices with separate administrative domains and controls, as well as route tables, switching tables, all of these bits. It's not something that you would typically do in a smaller shop or even, most mid-sized shops. You're only going to do this in a much larger shop or in a multi-tenancy environment where you've got the need to have separate administrative domains available to different groups. So if Jared and I were two different companies that were cohabitating the same facility for whatever reason, and I was providing equipment and Jared was a tenant of me, he could have access to this second logical system, this second administrative domain, and he would be able to manage his own connectivity, his own interfaces, routes, IP addresses, independent of me, while being confined to specific interfaces that I would be assigning him. So from the root logical system, I can assign resources, interfaces to his system, and then he can then manage those systems and that system and those interfaces. It's big, it's a lot, and in most scenarios unnecessary unless you find yourself in the very specific scenario. And if that's the case, then you'll know you need it and you need to implement it. But that's what a logical system is. All right, so root logical system is the base logical system where all the things reside if they don't reside somewhere else. Index is the policy index. So every policy from zone to zone has an index, and this one is 1. Here is our left and our right. Here is our allow ICMP rule. And here is our hit count. This actually might be the policy, or maybe this is the count. So here's our hit count. The number of policies, 1. So if we look at it again, it will show a significantly greater number. So we know that traffic is traversing from left to right, and it's matching the allow ICMP rule, so we know that traffic is going. Right won't show us that. However, the traffic is flowing. So if we go and we show our security policies, remember we deactivated this one, and we go activate from zone right to zone left, and we commit this. Well, it's already passing. It was passing because this is stateful. So left to right allowed the traffic to go, and since it's stateful, it was allowing it back. But what we couldn't do was initiate from right to left. So let's go ahead and let's roll back 1. Oh yeah. Roll back 1. So let's show security policies, and we see that it's inactive again, and we'll commit. All right, so the zone-based firewalls are stateful, so from left to right, and the return traffic was permitted. However, oh, no, this is ARP. Let's go ahead and stop that. All right, so what we could not do was ping from 192.168.2 to 1.10. So this traffic is not permitted. However, this traffic is stateful firewalling. If a session is initiated from zone left to zone right, it will be permitted, and the return traffic along the same identified flow will be allowed back. Since this is a new flow, because the source is from 2.10 going to 1.10, this traffic will not be permitted. However, we can go here, show security policies, and you see that we have our zone from right to left. And if we commit this, then our traffic from right to left will be permitted. There it is.
There we go.
So now we have bidirectional traffic initiated from both sides. Do keep in mind that, yes, these are zone-based firewalls with stateful traffic filtering. So while left can ping right, that doesn't mean that right can ping left. Left will get a response from right, but that doesn't mean that right can initiate the traffic. I refer to this as unsolicited traffic. The left will not be able to receive that unsolicited traffic from right because there was not a policy created. Once that policy was created, then the unsolicited traffic could be accepted, passed, and a response provided. This is important. Once you start looking at bigger security posturing and some of the vulnerabilities that can happen out there where it comes to stateful firewalls and NATs, NAT is not a security function, while people like to think it is a security function, and it does provide some security functionality. It is not intended to be a security function. It is intended to be a tool to allow you to make greater use of the limited IPv4 space. NAT can be exploited, not directly, but it can be leveraged, as well as stateful firewalls. In your home networks, up and up is a security vulnerability. Do keep that in mind. It is a very funny protocol, and it has very strange implementations. Do not enable up and up unless you must. Most commodity, off-the-shelf home routers, your Linksys, your D-Links, those types of devices will typically have up and up enabled by default because that's what gaming uses, but only use it if you must. Otherwise, shut it off. It's bad. Up and up is
good
bad.
Advice.
When you start looking at other more elaborate network vulnerabilities and compromises, there are different ways that people have been able to exploit NATs as well as stateful firewalling to be able to get traffic into a network for like command and control type of things, botnets, other types of exploits and data loss tactics, exfiltrations. So do keep in mind, again, NAT is not a security function. It is a network reusability, a network address reusability tool. It is network address translation, not packet filtering or traffic filtering. So that concludes this video. We set up 3 routers, one on the left, one on the right, and they're separated by the internet. So we were able to create a zone-based firewall in the middle with policies allowing left to right and right to left. We had the 2 devices left and right separated by at least one segment, one hop. So they had to create routes on both sides. So we used static routes to get from left to right, with the internet in the middle providing that zone-based firewalling experience that we were looking for. Again, these are the Juniper vSRXs, and good luck in your own adventures. In the next video, we'll be adding to this a little bit more. We're going to add one more internet router for a dual WAN architecture. We're going to leverage BGP for some simple route propagation. We'll be doing the same zone-based firewalls, security policies, but adding the protocol. So that concludes this video. Thank you, and see you next time.
Thanks. Take care.